Alright, so hello and welcome back to the walkthrough series, and in this episode we are looking at the 9618 variant 43 of October November 2023, and we are doing the Python solution to question number 2 of this paper. So let's go ahead and look at what we have here. So we have a linear queue that is going to be implemented using a 1D array called queue, and our first task is to declare the global variables for the queue array, or list as it were, the head pointer and the tail pointer. So let's go ahead and look at those going on here on lines 4 to 7. So you see that we have the queue, and basically we are initializing it to have a size of 50 on line 5 there, because that max size variable is being declared as 50, so it's a constant, is it? So we're just multiplying it with the size of that constant. Then the head pointer is going to be -1, then the tail pointer is going to be 0, is specified right there. And of course we'll go ahead and copy the code and paste it inside of the evidence document. The next item 2, we need to write program code for the procedure in queue, which takes a string as a parameter. Then if the queue is full, it outputs a suitable message, otherwise it's going to enqueue the item. So let's go ahead and look at the enqueue function right there. So on line 10, the function header, we are specifying here, this notation right here means that the item parameter, we expect it to be a string, is it? So that's what this the colon and the str there means. Then the none there simply means that this is a void function, it's not going to return anything. So it's going to help the interpreter, or it's also going to help whoever is going to be reading the code to show them that you know what you're doing. And then on line 11, we are telling this function that it should refer to the global variables head pointer and tail pointer. Then we are simply checking to see if the tail pointer is currently pointing at the maximum size. So it simply means that we do not have a space to enqueue any elements, so we are simply going to output queue is full. Otherwise, we're going to take the item that was passed as an argument on line 15 there and store it at the current position that is being pointed at by the tail pointer. Then of course, if the head pointer was -1, that is to say if we didn't have anything in the queue, we are simply going to set that value to 0, because we now have at least one element in the queue. Then of course, the tail pointer has to be incremented by 1, because the tail pointer always points at the next available slot. So of course, we'll go ahead and copy this code and paste it inside of the evidence document. Moving on to item number 3, we have the function dequeue, which essentially is going to remove an element from our queue, as it were. So let's go ahead and look at the function dequeue. One thing that you need to understand about dequeue, or rather you need to know about the dequeue, and they've also specified it right here. You cannot dequeue if the queue is empty, right? If the queue is empty, you're just going to print out empty. Then if it is not empty, then you're just going to return the element that is at the head pointer, as it were. So moving on to the dequeue function, again, this is going to return a string. So this is what this hyphen or this arrow looking notation and that str means. It simply means that it's going to return a string, because remember our array it's storing strings, or our list is storing strings, as it were. So we have the head pointer, the tail pointer we are telling the function that it's referring to the global head pointer and tail pointers, as it were. Then we have if the head pointer is equal to -1, or if the head pointer is equal to the tail pointer, it simply means that we have nothing in the queue, so we are going to return the string empty. Otherwise, we're simply going to take the element that is currently the head pointer and put it inside of that item variable. Then of course we need to update the head pointer by 1. Then if the head pointer, after being updated, it is now equal to the tail pointer, it simply means that we have nothing in our queue, as it were, so we need to set that value to -1. Then also the tail pointer need to be reset to 0. Then we are essentially returning item at the end of the function there, which is a string. Then of course we'll go ahead and copy this code and paste it inside of the evidence document. Moving on to part B, we have a function that's called read data, and essentially we're just going to be reading data from a text file called qdata.txt. And for me, I have a lot of files, a lot of project files that I have in this particular root directory. So I did call mine qdata n23 v43, n23 being November 2023 and v43 being variant 43. So this is the qdata file for this particular paper. There are also other qdata files for different question papers, so I had to rename it so that there won't be naming conflicts. So we had to read data from that particular file. So let's go ahead and look at the read data function. So you see that again, this is a void function, so we're specifying that it doesn't return anything, so we just point to a none there. Then we are going to open the file qdata n23v43 in read mode. Then we are simply going to read it line by line. Then if the line is not empty, we are simply going to take that line and strip any white spaces, any trailing white spaces, then and key that item into the list as it were. Then of course we're using exception ending on lines 40 and 41. Then of course you go ahead and copy the code and paste it inside of the evidence document. Moving on to part C, we are to create a record structure that is called record data, and this is essentially going to have two fields. It's going to have an ID and it's going to have a total. And you know by now you should know that whenever you're going to create a record, you're essentially going to create a class, be it you're doing Python or you're doing Java, right? So the way we're going to do it is here on line 44. So we have to declare the class in this constructor, because every class that you declare, if it is going to be a record or if it is going to be a custom data type, you need to declare it with the constructor, so that when you create an object, you just call the constructor. So here we have the constructor there on line 47 to 49, right? Then we would be done with this part of the question. So you simply go ahead and copy the code and paste it inside of the evidence document. Moving on to item number 3, we have to declare global 1D arrays, one called records, rather global variables. One is in 1D array called records, and the other one is a variable called number records, is it? So we come to our code right there. You see that these are the global list and variable respectively, initialized to 0 for the number records and with the size of 50 for the records list as it were. Lists are the equivalent of arrays in other programming languages. That is, if we're in Python, we use lists. Then of course you go ahead and copy this code and paste it inside of the evidence document as it were. Moving on to item number 3, we have this pseudocode right there. So we have a procedure called total data. There's a data accessed string. There's a flag called boolean, and there's also, we are in dequeuing an element and storing it inside of this data accessed variable, right? And then we are doing all those things right there. So just to summarize what's going on there, they give us a description of what this function is trying to accomplish. So it's going to dequeue an element, that is remove an element from the queue. Then it's going to check whether the record with the returned ID exists in records. Remember, records is the global array that we've just declared in the previous part of the question. Then we are going to increment the total for the ID in the record if the record already exists. Then we are going to create a new record and store it in records if the ID does not exist. So let's go ahead and look at this equivalent implementation in Python. So the first thing that we need to do is we need to dequeue an element and store it inside of that data accessed variable. So we are referring to the number records global variable in line 59 there. Then we dequeue an element, then check to see if it is not empty, then we simply return. If it is empty, we simply return. Otherwise, if it is not, we are going to otherwise we're going to proceed and iterate through the records data structure. However many records that we have going on there, is it? So if that's inside of the loop, we are checking to see if the data accessed is equal to the ID of the element at records index position I. So if it is the same, then we are incrementing the total as they specified right there on line bullet point number 3. We're simply going to increment that the value of total by 1, and then we return. Then at the end, we're simply going to take that record object and store it inside of we are to create a new record and store it inside of the record. So we are creating, you see that we are calling the record data class right there and passing the string ID as well as the count right there. Suppose you see that it's going to take the total basically. So it's going to take the ID, right, and the total right there as parameters. Then we are creating that as the new object and we are storing it inside of the records list as it were. Then of course we need to update the value of records. Then next up we have item rather D. We are to create a function called output records, which it's going to output our variables inside of in the format ID, then the ID, then the total and the total. Right. So essentially this is going to be, let's say if an ID appears one time, right, it would be, let's say, ID, the ID, then the total number of times it appears. So this is essentially what the output records function does. So we are simply going to iterate through the number of records and take the ID and print it. Then the total we print it, is it. So we're just printing it so that we have a space in between going on, as they've highlighted right there in that question. So of course you'll go ahead and copy the code and paste it inside of the evidence document. Moving on to part E, we are to call read data, call total data for each element in the queue, and we are also to call output records, right? So let's go ahead and scroll all the way down to the main function. So read data, calling on line 81. Then we are making a conditional call to total data, right? We first dequeue an item, then if it is empty, we simply break out of the loop. Otherwise, we are going to enqueue the item and call total data so that we count the total number of elements that would have been enqueued inside of the records array. Then ultimately, we are simply going to output the total number of records there on line 91. Then we are to test our program and take a screenshot of the output. So let's come, let me open the console, clear the screen, then I'll run the file one more time. Did run it earlier on when I was testing the file. So you see that we have the output going on there. So you go ahead and take a screenshot of the output and paste it inside of the evidence document as it were. So yeah, that's just about it for this question and for this video. I'll see you guys in the next one.